Hello and welcome to Barkland Labs. Today we are talking about a Newton's Law lab. This really incorporates all of Newton's laws, but particularly Newton's second and third laws. So, the materials involved. I'm going to call this a Newton's car or a Newton's slingshot. It's just a piece of wood that I cut with a couple of nails that I put in here. Got to be really careful. I almost impaled my hand on a nail. Those are they're still sharp, even though it's the other end of it that you could hurt yourself. So be really careful to not impale and avoid any impaling in this class. Other safety issues to be aware of. Got to make sure that you are wearing your safety goggles at all times. And then I want every group to also have just a wet paper towel with them. Shouldn't be left out in the hallway, but this is because we are using some fire in this lab, and if something was to catch on fire that you wanted to douse really quickly, it's just nice to have something on hand that you can quickly just put it out with. Okay, so the Newton slingshot involves reducing the force of friction by placing some dowels. This is a dowel right here. This is not a percussion instrument, which is what it's going to be tempted for you to turn this into. It's not an implement to strike your buddy with. This is just a way of reducing the friction so that this Newton slingshot can roll along kind of like a car. If this proves to be too difficult for you to work with, I can give you a very small dowel that will no longer work very well as a striking instrument. So, you take your slingshot and you need to set it up by tying a string. So you've got a piece of string here, and you're going to tie a loop. And I want you to shoot for making your loop about the circumference of a golf ball or so. You'll see why that size works pretty well. And I'm going to show you kind of a bad example, and hopefully this is going to be a good example for us. So that's maybe a small golf ball, about yay big. I'll put that next to my hand for scale. There we go. And I'm going to go ahead and cut that off right there. So now that you've got that ready, what I want you to do is I want you to, on your piece of paper, actually draw how big that circle is, because this is a massive control variable that you want to make the same size loop every single time. So you're going to grab your rubber band, and you put your rubber band through one of the nails, or around one of the nails, and then you can actually put it through your loop. Okay, if I can figure this out. Put it through your loop like that, and then connect it to the other nail. So now it will be going down like that, and what you can do at this point is you can pull the rubber band down that way. Now you want it to be seated a little bit higher on the nails, and same thing with your string, a little bit higher. Notice we've got some gap between the rubber band and the car. And then what you will do is you will put your ammo, which is a cube, onto the slingshot. The different kinds of cubes we have: lead, which is obviously very dense, so this cube is pretty heavy. We've got acrylic, which is not very dense, so very, very light. We've got aluminum, copper, brass. We'll actually make some brass later this year. Steel, which is mostly iron, a little bit of carbon, and I think that is it. Yeah, so you've got 6 different blocks. You're going to actually use the scale to find their masses, and what you will do is you will go ahead and place those blocks inside of your rubber band. Now, I'm hoping that you see that the size of the circumference of the string you tie will affect how far this block is pulled back. So the reason it's a huge control variable is if you're tying different lengths of strings, you're going to be applying different forces to this block every single time, and you want to be as consistent as possible with that force. So we've got the copper block on here now. You can set it on the front of your dowels. So if I move this, you can see the slingshot is aimed that away. And you are going to now grab the flame Notice these are set apart maybe about 3-4 centimeters. You don't want to do really any closer than that or any further than that. That's another control variable, though, is about how far you spread these devils out. So now what you're going to do is you are going to put the flame over here, and okay, so our car went off the table. I knew that would happen. You're not going to do this on the table. You're going to do this out in the hallway or in the classroom, depending on where I assign you. And what you are going to measure are two things. You're going to measure how far the cube flew and how far this block itself flew. That's going to tell us something about both Newton's second and third law. The fact that this car went that way while the block went that way is demonstrating Newton's third law, the idea that for every action there's an equal and opposite reaction force. But they didn't go the same distances, and that has to do with Newton's second law, the idea of F equals ma. The amount of force is equal to the amount of mass times the acceleration. The car and the block, and then as you change the mass of the block, it will change something about that reaction force. So you are going to measure how far the car goes, and you're going to measure how far the block goes as a way of measuring the force applied on each object. So we're not directly measuring the force, we're kind of indirectly, by proxy, measuring how much force is applied to the block. The assumption is that if more force is applied, it'll go further, or if less force is applied, it won't go as far. And that's how we're going to illustrate Newton's second law. So going back to the safety things, sometimes your string can stay burning after you're done, so you want to grab that paper towel just in case this is catching on fire. We don't want to start any fires in the hallway. I don't want to get a reputation as that teacher whose kids are always setting things on fire, so you've got this just in case this is on fire, and you can go ahead and douse that. Obviously, you do not want to just be constantly lighting this lighter. Only light it for when you actually need to light it, and you'll notice that this is duct tape. That is not a style points there. That is because somebody broke this lighter, and I've got several of these that were broken in the last couple of years. So just be careful with these. You can snap that if you are not being careful. You can see that is shifting. It still works, but let's just be careful with that. So once again, Newton's second and third law. And Newton's first law is being illustrated by the fact that this was motionless until an unbalanced force was working on it. The unbalanced force was the rubber band pushing that way, and it moved the other way. So that was Newton's third law, and then they moved different amounts based on Newton's second law. Welcome to Barkland Labs, or welcome back to Barkland Labs. This is an addendum to the previous video that I wanted to address a few control variables and things to be careful about in your lab. So first has to do with how we measure. So if you look at our setup here, I'm going to put our car here. I've had people make this mistake before. You need the car facing that way in terms it'll fling the block, the cube, away from this trajectory, and the car's going to go backwards on here. Here's a super important part. You need to put something like a marker down right at the front of where that car is, or you could do where the block is if you wanted to, or you could even do it at the back of the car. Doesn't really make a big difference. And the reason for that is that's going to be our reference point for where we measure how far the block went and how far the car goes. So let's go ahead and put something in here. This is acrylic. I also forgot to mention that this is zinc. It's kind of the dull colored metal. I think I forgot that on the previous video. So let's go ahead and put that acrylic block in here. Kind of lodge it in there a bit. Okay. So I'm going to light this. And here's another control variable you need to be really careful about. A lot of times people don't pull the lighter back fast enough when they're lighting it, and it gets hit by this nail, or it accidentally hits the rubber band, something like that. So first off, don't have it too close. You might want to have it a little bit further so the flame that protrudes can hopefully just light it from a little bit further away. You might want to pull the lighter back every now and then, like I'm doing right now. Let's go ahead and give that another try here. Oh, it's about to go. Oh, there we go. Okay, wow, that went really far. This block didn't go that far, but the acrylic block actually hit the wall. This is why I'm having you do this out in the hallway. Now, we've got our purple expo marker here. What you would do, grab your meter stick and measure from the marker to the car. So that is 19 centimeters. And then you do the same thing, measure from the marker to wherever the block went. And as I said, the block actually hit the far wall. But you can see the acrylic block right there. I'd start here at the marker and then go from there. It's really important to know where your reference point is or where you are measuring from. A few other control variables. You want to make sure to use the exact same car every time. If you take a look, oh, these are actually the same size. Dingus and unnamed. That's the same size. Okay, so for example, these two, notice that these have different lengths. That was Sunshine. Sunshine is a longer block. What that's going to do is it's going to allow you to pull the rubber band back further, so that would launch further. You wouldn't want to, if we did this over multiple days, mix up your blocks or get your block mixed up with somebody else over the course of the experiment. So I recommend you label it with your name. I'm planning that Monday and Tuesday block periods are the only days we do this, but just in case we do have to spend extra days, make sure that you write your name on that block. Another thing you can do, I already talked about this, huge control variable is how far this string pulls back the rubber band. So you want the same diameter string, or you could also maybe take a pencil, not a marker, and make a mark right where that junction between the rubber band and the string is, so that you make sure that you are pulling it back to about the same spot every time. Otherwise, you're going to be varying the force, and since we're studying Newton's second law, we want to keep the force the same and vary the mass and see how that affects the acceleration of both the cube as well as the car. I think those are about it for the things that I wanted to add on to that. Hope you have a lovely weekend. See you all Monday or Tuesday.